Yeah. Good afternoon. I would like to introduce a new product, actually a new product generation we introduce here at this show for the first time. The product was announced yesterday and we exhibited today at booth B3. The product is designed for long-term storage, for archiving, and what we want to do with this product, we want to offer a scalable, highly reliable product which stores data forever and which does not have the requirement for data migration. So what I want to do today is I want to give an overview over the technology of this Everspan product and then explain the Everspan library. I want to go through the product features and the customer benefits and then show the availability and the roadmap for this product. Why are we introducing this product? There are capacity needs, there are needs for retention periods, and these retention periods are getting longer and longer, and they exceed the life of typically used media for archiving. Like a tape or a hard disk has a definite end of life, and it actually depends on the use of how we use these media. So what we do with this product here, we offer an archive which is where you can store your data virtually unlimited for an unlimited period of time. So if there is a need for a combination between a retention period, long retention period, and high capacity, then the Everspan product is the product to use. So the technology we use for this product is what we call the Archival Disc, and it's a optical technology which is using the blue laser. Now, you know the consumer technology, CD, DVD, and Blu-ray, but that is the past. The product we are introducing here is unrelated to these consumer technologies. We are introducing a professional archive technology based on optical. Completely different, and I will explain to you what is different and why we are introducing and using this technology in our product. The Archival Disc is a dual-sided disc. It has 3 recording layers on each side, and we have a protective layer on top of the media on both sides so that this medium has a medium life, a medium reliability of more than 100 years. Actually, we give a warranty for this media for 100 years. The drive we are using with these media is a drive which can write both sides of the media at the same time. So we have a laser on top and a laser on bottom, and they write and read concurrently. But all this would not give us the performance we need in this marketplace. In this market, we need to be able to restore files real fast, meaning we need to get back a file, let's say a petabyte file, within a short period of time. What I show you here on this right-hand picture is one laser on top and on bottom, and that would not give you the performance you need to fulfill these requirements. So what we are doing is the following. We are using a drive which has 4 lasers on the bottom and 4 lasers on top. And then the drive is a dual-side drive, so we read and write concurrently with 8 lasers at the same time. That gets us to a transfer rate of 280 megabytes per second, and here you see the peak transfer rate is about 315 megabytes per second. Now, 315 megabytes per second, that is faster than LTO7, that is faster than hard disk. So what we are doing here is something with optical which has never been done before. Optical at 300 megabytes per second is completely new, and we want to use that as the heart of our machine. So in our machine, we have, of these drives, we have up to 64 drives. That times 280 megabytes per second gives you a sustained system transfer rate of up to 18 gigabytes per second. 18 gigabytes per second. Now that is very fast. That's not achieved by any tape library. So this is something, we offer here something unique in the archive market. So this drive we call an array head drive, and we have, as I said, 8 lasers per drive. That allows us a restore of about 1.5 petabyte a day with 64 drives. And on the upper right-hand side, you see a throughput chart for the different technologies. The most upper is the maximum transfer rate for optical, for our drive. And the yellow one is LTO7. So you see that we favorably compare to these technologies. On top of that, we continue to use the reliability features of optical storage. That means we give, for the media, we give a 100-year warranty at the given temperatures. At very high temperatures and humidity, the media life can be 50 years, but in a normal data center environment, the life of the media is 100 years, and we give a warranty on the media for 100 years. Now, in our application, we introduced the library with a object store interface, and on top of that, to increase the reliability of the unit, we also use erasure coding so that we get a very fast transfer rate, and in addition we get the high reliability. So the combination here of performance and reliability is something new in this market. There is no other technology and there is no other medium which can offer these reliability and performance values. So we designed a library where we install these drives and media. We added a high-performance drive. We add the media with the high density. The media capacity is 300 gigabyte. And then we add an enterprise class drive and the reliable media into one system, which you can scale up to 180 petabytes, and what gives you the reliability and performance forever. Sorry. So this is the unit you also see here in our booth, B3. We have a scalability in this unit which allows us to increase expansion units. So this unit you see here is a 12 petabyte unit, and you can expand this unit in a row design which is used in data centers to 180 petabytes. In addition, our drive and media have the advantage that they are compatible across the generations. So as we improve further the capacity and transfer rates, our media will be backwards compatible in the newest drives. This is something new. In tape, you have to replace drives after some times because you have the new technology, but then the old media can no longer be read. This problem does not exist in our library. Now, the low power consumption is another very important feature in our product. The typical power consumption for 180 petabytes is 7 kilowatt. This is what you typically would use for a hard disk rack for a single rack. And a single rack may have 4 or 6 petabytes. So you see the difference here between using a hard disk or an optical solution for long-term storage and the advantages from the power consumption. So here you see a picture which shows the Everspan product. In this area we have what we call the drive unit. Then we have a robotic unit, and then we have what we call the expansion unit. And these expansion units we can add to and get to a total length for this product of about 55 feet. So we add in a row design more expansion units to the base unit, and the robotic is here in the middle and then moves media to this drive unit, and the drives then are loaded with these media. Now, we are loading 4 drives at the same time. We have a robotic in this unit which has a 4-drive loading mechanism. So we have the media and 4 drives are loaded into drives. And then since we have media stacks, we can continue to load drives up to 64 drives with one robotic axis. That means we can load the 64 drives very fast and then get our 18 gigabyte per second bandwidth. The rack dimensions comply with the OCP standards. So the standard OCP rack has similar dimensions. So let me go back here. In this view, we show the robotic in this area and then the drives here. We have a robotic which transports the media, and then we have a second robotic which loads drives. So these 2 robotics work independent of each other. So we can move media to the base unit to get loaded into the drive while we are loading drives already. So this is an independent activity so that we can continue to load the drives fast. So this is what you see here. The linear robotic is catching a tray with media from the expansion units, and then we bring these trays to what we call a staging area, and from the staging area it's moved to the drive robotics, and then we load the drives. We can load, as I said before, 64 drives consecutively. So we load the whole media stacks, as you see here, into the robotic, and then we continue to load drives consecutively. So when you see a full expansion unit device, you see that here on the right-hand picture. We have the base unit here, and then we can add expansion units, and then this unit has the 180 petabyte capacity. This unit is configured with 300 gigabyte media and 300 gigabyte drives, and that gives us 180 petabytes of capacity in the system. The expansion units, when they are adding very little power to the power consumption in the system. So the total system you see here with 181 petabytes has this 7 kilowatt power consumption. We will launch this product actually right now. The announcement was yesterday. We have installation at customers right now. They are in beta testing. In our announcement, you also find comments from our customers we are working with. and we are doing a product demonstration in our booth in booth B3 here at OCP. First production units will ship in July 2016, and we follow the announced Everspan roadmap, going to 500 gigabyte media and then to 1 terabyte media and beyond that. So please visit us in booth B3. We demonstrate a functional unit there, and you can see the operation, and we will explain how things work. You're welcome. Please visit us in our booth, but you can also find information on our homepage under info@everspan.com. Thank you.